Let's see this question. Construct the minimal DFA that accepts all strings over the alphabet A comma B, where each string has even number of A's. So each string has even number of A's. It means when number of A's in the given string W are divided by 2, we get a remainder of 0. It can also be written as the number of A's is congruent to 0 mod 2. When we divide the number of A's by 2, it leaves a remainder 0. Right? So the language will have all the strings having either 0 A's or 2 A's or 4 A's or 6 A's or 8 A's or so on and so on. So the set of strings having 0 A's will include epsilon, B, BB, BBB and so on. It can be, we can represent it as B star. So it is like 0 or more B's, any number of B's. So all these strings will have 0 A's. Similarly, we can have strings having exactly 2 A's like AA, BAA, ABA, AAB and so on. Right? In the same way, we can have strings having exactly 4 A's and strings having exactly 6 A's and strings having exactly 8 A's and so on. So clearly this is an infinite language. And we don't know whether we can draw a DFA for such an infinite language or not. So let's try drawing a DFA. Since epsilon is in our language, our initial state will be final state. Right? Let's say this is Q0. And the next minimal string which is in our language is AA. On seeing A, we go to Q1. On seeing A at Q1, we go to Q0 and accept this string because this has even number of A's and we have reached the end of the string. So we need to accept this string. So we reached Q0. Since we don't have any constraint on B, we just skip them whenever we see. So on seeing B from Q0, I will be in Q0 itself. On seeing B from Q1, I will be in Q1 itself. So this DFA can accept all the strings having even number of A's. You can try this string AA. So on seeing A from Q0, it goes to Q1. On seeing A from Q1, it goes to Q0. On seeing A from Q0, it goes to Q1. On seeing this A from Q1, it goes to Q0. Since we have exhausted the string and we reached the final state, we say that this string is accepted. You can consider any string having even number of A's. This DFA is going to accept it, and this DFA is going to reject all those strings which does not have even number of A's. Now consider BA, let's say this string ABAA, it has 3 A's. So this is the number of A's is not even. So let's see how this DFA behaves on AABA. On seeing for ABAA, on seeing A from Q0, it goes to Q1. On seeing B from Q0, it will be in Q1 only. On seeing A from Q1, it goes to Q0. On seeing A from Q0, it goes to Q1. Since we have exhausted the string and we didn't reach the final state, Q1 is not a final state, we say that this string is rejected. This is not in our language. So this DFA accepts all strings having even number of A's, and indeed this is a minimal finite automata indeed, because we cannot reduce the number of states less than 2. The number of states in this minimal finite automata is 2. Let's look at this problem in a different perspective. So we are asked to construct a DFA for all the strings having even number of A's. It means when the number of A's is divided by 2, we need to get a remainder 0. So when we divide a number with 2, what are the possible reminders? It can be either 0 or 1. When do we get a 0 as reminder? When we divide an even number by 2, we get a remainder as 2, right? Sorry, 0. When we divide an odd number by 2, we get a remainder as 1. So there are two possibilities, two possible reminders. This can also be written as WA is congruent to 0 mod 2. It means when we divide the WA by 2, we get a remainder 0. Since we have two possible reminders, we will have two states in this DFA. One is for recognizing all the even number of A's seen so far, and the other is for recognizing all odd number of A's seen so far in the string. Since we are concerned only about the even number of A's, that is 0 reminder, we will make Q0 as final state, and this is Q1. This is Q0 is the reminder when we divide the number of A's seen so far. 1 is the reminder when we divide number of A's seen so far by 2. Right? Always remember Q0 will be our initial state. So when we see an A from even state, we go to Q1, which is an odd state. From odd state, when we see an A, we go back to even state. And whenever we see a B at any state, we just simply skip it because we don't have any constraint over B. The same thing happens at Q1 also. When we see a B, we just skip it and we don't go to any other state. We will just be in that state. We only consider the number of A's in this DFA. So this is the DFA for accepting all the strings having even number of A's. Let's say we need to construct a DFA for strings having odd number of A's. We can also write this as 1 mod 2. That means when we divide the number of A's with 2, we get a remainder 1. So here also we will have two possible reminders. So the DFA will have two states, Q0 and Q1, because our reminders are 0 or 1. And remember, always Q0 is the initial state. Since we are concerned only about the odd number of A's, we will make Q1 as final state. And transition over A, we go to Q1 on seeing A from Q0, and on seeing A from Q1, we go to Q0. On seeing B from Q0, I will be in Q0 itself because we don't have a constraint over B's. And on seeing B from Q1, I will be in Q1 itself. This is our minimal finite automata for strings having odd number of A's.